Hello everyone, back again with me, Sir Julius, in physics class. So for today, we still learn about static electricity. For today, we will learn about Coulombs Law. So without further ado, let us start our lesson today. Okay, so we've already learned about particles and charged particles. So now let's see from the picture. Now I have two particles that have the same charge. On the top part, both of it are positive, meanwhile on the bottom part, both of it are negative. So if I have two particles that have the same charge and next to each other, they are going to repel each other. So they have a force of repulsion. Meanwhile, if I have two particles with different charge, the first one is negative and the second one positive, and in bottom part the first one is positive and the second one is negative. When the particles with different charge are next to each other, they will attract each other, or we call it they will have force of attraction. So this is the property of matter that we can observe. So we've already know how these different charges start to interact with each other. But the question is, how about the magnitude of the force? We can only know that the charges will be attracted to each other or repelled to each other, but we don't know how strong the force of attraction or force of repulsion of that interaction between charges. So in 1785, French physician Charles Augustin de Coulomb, he finally published his experiment about the magnitude of the force between two charged objects. We call it now Coulombs Law. So what is Coulombs Law? Coulomb states that the electrical force between two charged objects is directly proportional to the product of the quantity of the charge on the objects and inversely proportional to the square of the separation distance between two objects. Or we can write it in equation form: F equals to K times Q1 times Q2 divided by D squared. So F in here is force between two particles, or we can call it Coulomb's force or electrostatic force, and the unit is in Newton. And Q in here is charge of the object. The unit is Coulomb. So Q1 is first charge of the object and Q2 is second charge of the object. D in here is distance of separation between two objects. The unit is in meters. And K is the Coulombs Law constant. Coulombs Law constant is approximately 9 times 10 to the power of 9, and the unit is Newton meter squares over Coulomb squares. So this is the example. A point charge has a magnitude of positive 15 nanocoulomb. A second charge has a magnitude of positive 15 millicoulomb and located 5 cm from the first charge. Determine the force each charge exerts on the other. So we have first charge equal to 15 nanocoulomb, so we can convert it into 15 times 10 to the power of negative 9 coulomb. And the second charge is 15 millicoulomb, so we can convert it into 15 times 10 to the power of negative 3 coulomb. And then the distance between two charges is 5 centimeters, so we can convert it into meters. 5 times 10 to the power of negative 2. And the constant is 9 times 10 to the power of 9 nanometer square over Coulomb square. Okay, so now we will go to the formula. The formula is F equals to K times Q1 times Q2 over D square. So F equals 9 times 10 to the power of 9 times 15 times 10 to the power of negative 9 times 15 times 10 to the power of negative 3 over 5 times 10 to the power of negative 2 square. So how can we solve it? The first thing we must do, we can see that 5 times 10 to the power of negative 2 square, we can change it into 25 times 10 to the power of negative 4. We can use the exponent operation in here. So what am I going to do is I'm going to separate the numbers. So the first one is the 9 times 15 over 25, and then times 10 to the power of 9 times 10 to the power of negative 9 times 10 to the power of negative 3 over 10 to the power of negative 4. So the base number is all the same, so we can use the exponent operation in here. So 9 times 15 times 15 over 25 is equal to 81 times 10 to the power of 9 minus 9 minus 3 and divided will be negative minus negative 4. So we have F equals to 81 times 10 to the power of 1, or 81 times 10 equals to 810 Newton. So if we have two conditions of interaction between charges, we can write it in ratio or proportion. So we can write it in equation form. First force over second force equals to, we've already know from Coulombs Law that the product of two charges is directly proportional into its force. So first charge in first condition times second charge in first condition over first charge in second condition times second charge in second condition. We've already know from Coulombs Law that the distance between the charges is inversely proportional into its forces. So you can write it as second condition distance square over first condition distance square. So now we will go to the example. So two identical charges are repulsive to each other with 4 Newton force of repulsion. The distance between two charges is 7.5 millimeters. If we change the distance between two charges to 15 millimeters, find the force of repulsion between these charges now. So in this question, the one who changed is only distance. So we can write the ratio or the proportion between F and the distance. So first F equals to 4 Newton, and we must find the value of second F. The value of the first distance is 7.5 millimeters, and the second distance is 15 millimeters. Okay, for the example, we know there are two conditions. The first one is when two identical charges, the distance between them is 7.5 millimeters. And the second one, when the distance between two charges is 15 millimeters. So the charge is not changed. So we can write it as first force over second force equals to d second d square over first d square. Okay, because the distance is inversely proportional, so you can write it as F. So the first F is 4 Newton. For Newton, we must find the value of second force equals to B. Second distance is 15, and then the first distance is 7.5.
Jadi bisa kita gabungin ya, ini kan D2 kuadrat dibagi D1 kuadrat. It's the same with D2 divided by D1 squares. Okay, so after it, now 4 over F2 equals to 15 divided by 7.5. We have 2 and this one is 1. 2 over 1. So 2 square divided by 1 square. So we have 4 over F2 equals to 4 over 1. Bisa kali silang. So we have 4 Newton equals to 4 F2. So we have second force is 4 divided by 4 equals to 1 Newton.
Now for the next example. 2 point charges have a magnitude of 6Q and negative 8Q respectively. These charges are 3D apart from each other and attracted to each other with F Newton force of attraction. Determine the force of attraction if the charges are 4Q and negative 6Q respectively and 4D apart from each other.
Okay, so now 2 point charges have a magnitude of 6 and negative 8 respectively, and these charges are 3D apart from each other and attracted to each other with F Newton force of attraction. Now we have second condition. The charges are 4Q and negative 6Q respectively, and the distance is 4D. So because both of it is changed, so we can write it as F1 over F2 equals to first charge in first condition divided by this one first charge in second condition times the distance is inversely proportional, so we have D2 square over D1 square. Okay. So now I have the first F is F and then equals to the charge is 6Q and 8Q over 4Q and 6Q. So the Q we can divide it. Now 6 divided by 6 equals to 1. 8 divided by 4 equals to 2. Meanwhile, the distance we have 4D is the same. We can write it in parentheses. 4D over 3D square. So the D, we can divide the D because D is the same. This one is over F2. Okay, so after this, we have F over F2 equals to 2 times 4 square divided by 3 square. Jadi dua-duanya dikuadratin ya, jangan lupa. So F over F2 equals to 2 times 16 over 9. So we have, ini bisa dikali silang, so we have 9F equals to 32 second F. So we have the value of second F equals to 9F over 32. So this is the answer.
Okay, so that's it for today. We've already learned about Coulombs Law. See you again next time in another physics class. So bye!